Hi to everyone and welcome back to this new video about YubiKey, in which I'm starting to explain something more developer-oriented features of YubiKey. And today I want to show the basic feature of SSH with YubiKey. I don't want to explain how SSH works, but basically when you want to log in or to access an external system with SSH, you usually have a couple of files. One is the private key file and the other is the public key file. You need to put the public key part on the remote server. And then when you log into the remote server, you need to explain to the remote server that you have your private part of the key. So there is some cryptography behind that makes this kind of authentication really, really secure, because only a person that has the private file with the key can access the remote system. With YubiKey, the security can be really improved, because instead of having the private key part in a file, usually password protected, you have your private key part inside your key. So it's much more difficult for an attacker to steal your credential, because they need to have access physically to your key. In the console, you can see how you generate a key using your YubiKey. So the only thing that is different is the type of algorithm you choose. You must choose an elliptic curve algorithm. Usually use the ED25519, and the -SK part of the type is the key of everything, because it is telling to the SSH algorithm to generate a key that must be stored inside your YubiKey. So let's press enter and let's see what happens. The system is telling me that some program is trying to access my key. I press OK, and this will let SSH see the make and model of your security key. OK. It is the very, very same experience you have when you use FIDO True account. Now I need to touch my key, and there you go. It is asking me a passphrase, okay, a password to protect my local file. This is usually the part when you enter your strong password for your private key file, and that is needed for the standard RSA file. Now, since the real private part of the key is in my YubiKey, there's no need to use a password. So I usually press enter and choose a blank password. And here you go, your password is generated. Now you can see I have some lot of key in my system, and the demo key is my new key. So I can type the demo key, public part of the key, and you can see that it's an SK-SSH. So it's a security key SSH, and it is much smaller than an RSA key. So that's the public part, and nothing new. And it's a standard way for SSH to encrypt, to store the public part of your key. Now I can dump the private key. So usually when you have an RSA key, you have rsa.pub, it's your public key, and RSA, that is your private key, it's private part of the key, and usually password protected. In this situation, I've not set a password, so I can simply press enter, and what you see is the private key. But actually, this is not the real private key, because this is a reference that tells where, in which key, and how to retrieve the real key from your YubiKey. So actually, an attacker using this file cannot do really much more. It cannot use only this file to enter the system, because it has no access to the physical key. Now, once you have a valid public and key files, you can use the public key in a remote Linux server for accessing through SSH. This is the most common usage. And actually, you usually use the SSH copy ID command, but unfortunately, this command is not included, at least in my version of SSH, is the latest I've installed. It's not included in Windows. But it's not a problem, because the obvious solution is to manually copy the public part of your file into the known host on the remote server. So it's nothing complicated, and I show you how to do this manually. So the first step is going to SSH into your remote computer using the standard username and password. So I'm using SSH username, had the ID, the IP address of my server, and I'm typing the password and I'm in. Now I need to copy the public part of my key inside this remote server. So I'm usually open a new tab in my terminal, and then I type my ssh demo key.pub file so I can have my public part of my key. Now you can copy the public part of your key, and you need to edit the SSH authorized key. So actually, if you go to your SSH part on your remote system, if it's empty, it has no file inside, no key, no authorized key. So you need to just copy this public key into the authorized key file. If there is already an authorized key files, you just need to append your key in a new line. So a usual trick if the authorized key is not present is just to echo the whole key into the authorized key files. Now I can exit my SSH session and try to go again into my file and into the remote system, and it asked me the password. And that's the reason for this, is because I have multiple SSH key in my system, so I need to specify the key. This is a common situation, especially when you have YubiKeys, because as I told you, you usually have more than one YubiKey just for backup. So it is normal for you to have multiple keys generated, one key for each one of your YubiKey. And so it is common to have multiple SSH key in your profile, in your .ssh directory. So you need to specify the key file you want to use for the server. So in this situation, if you only specify the username at IP address, it will use the standard RSA key that I have in my system, because this is the standard. This is not the correct key, so it fall back to use password. But if you specify the name of the private key you want to use, the SSH protocol will use the correct key. Now, let's verify that everything is working correctly. I press enter, and here you go. The system is asking me to confirm my user presence. So I can touch my key and I'm in. So I can cat my ssh.authorized key. So the only thing I need to do is copy my public part into the authorized key. And then, as you can see, when I want to access my system, I can just type the SSH command, touch my key, and I'm in. Since the need to use the -i option is usually annoying, you can always create a config file into your .ssh folder. So no need for special extension, just a config file in which you can use this kind of syntax. So host and the name of the host name, I can use the IP address and my user. So the user must be Gianmaria, and the identity file I want to use. So using this kind of config file will make the SSH default for this host with a specific user and a specific key, and it makes much more useful and much more easy to access your system. The final situation is, thanks to YubiKey and thanks to a good config file, I can simply SSH and specify the IP or the host name, and it actually check the config file, verify that there is an entry for the 10.0.0.0.217, and it asks me to touch the key, and I enter with my username. So it's just SSH, hostname, or IP address, touch your key, and you're in a very, very, very secure way. To conclude this video, which are the advantages of using a YubiKey to access your SSH server? Well, it's always security and easy of usage. As you can see, it's very, very easy. You just need to type SSH command, the address of your server, touch the key, and you're in. But you have an advanced security because an attacker, to access the system, need to have physical access to your YubiKey, and also have the private key part that contains usually a set of information that allow SSH protocol to identify the key and extract the private key. So it is very secure, and it does not require you to use any SSH credential manager. When you use a standard RSA or ED curve cryptography, but not using a physical key, the problem is you have your private key in a file, and usually you need to use a very, very strong password to secure the file, because if an attacker can access the file and crack the password, he or she can access all of your systems. So you're usually using a super long and super complex password. But the drawbacks is each time you need to log into your system, you need to type this very long password, and that brings a problem, because the standard user does not want to have the problem of typing a long password. So either a couple of options occurs. First, the user choose a weak password, or you use an SSH password manager. So something like it's a daemon that listens for your password and memorize. So the first time you do an SSH command, it asks for your password, and every time you need to reuse the SSH key again, it will reuse the password stored in memory to automatically decrypt the file, not asking you to enter the password each time. In this scenario, if an attacker tricks you into clicking a link or running a script, the SSH password is in your memory. So if an attacker can issue an SSH command through a server made by your user, there's the risk that the credential manager automatically decrypt the private key part. With the YubiKey, you don't incur into this risk because the attacker need to physically have access to the key. And even if an attacker trick you into clicking in something, running a script, you need to physically touch your key to enable the accessing to the remote server. So usually it's much more difficult for you to just maybe you click a link, your system get tricked into issuing an SSH command, and then you need to touch the key. So it's usually difficult for you to be tricked not only in clicking a link or running a script, but also in touching the key. So this is the extra layer of protection. So in my opinion, it's a very good way to use SSH key because it's one, easy, and two, secure, and everyone can use with great success. It is one of my favorite features of my YubiKey. Thanks for watching, and I'm waiting you for my next video on this YubiKey series.